All right, let's do it. Well, I would like to, first of all, thank everyone that's on this call, from the panelists that's kind of heading the discussion today, to each and everybody out there who's joined in by phone or computer. We certainly thank you sincerely for taking your time out of your busy schedule to join us for this hopefully fun discussion. I'm sure you still have plenty of items on your to-do list today, and we appreciate you putting those off for the next 20 minutes or so to listen to us talk and rap quixotically. As most of you know, a big priority at Safety Cover is education and discussion of anything related to the water industry. We love talking about things and getting discussions going. When I travel around the country, the presentation I give most often is our best practices in backflow preventer installation. So we discuss local and national trends and specifications and standard details. We kind of just discuss the who, what, when, where of backflows that are installed in your jurisdiction. And then I kind of compare that to trends that I see across the country. And you'd be amazed at how much time you can spend talking about those things. Of course, I always mention the features and benefits of Safety Cover, but the crux of my conversations are always centered around education and protection of the water supply. So if you guys get a chance, if you haven't already, please check out our website, safetycover.com. We have numerous educational guides. We've got a really active blog community where we welcome healthy discussion on all topics related to water. So kind of in the spirit of that discussion and education, we kind of put together this panel discussion today about vaults and underground installation of backflow preventers. We thought it was a topic that a lot of you are familiar with. A lot of people discuss it on a regular basis. People all around the country are constantly arguing the pros and cons. I see it all the time. So today we've assembled a good cross-section of the water industry to discuss this topic. I'll be moderating the panel today. For those of you who don't know, I'm Cleary, National Sales Manager for Safety Cover. My background is kind of steeped in backflow. Over the past 21 years, have been the National Sales Manager for Watts, Ames, Febco, and Apollo. So I know the backflow industry pretty well. I know the differences and similarities of just about all the backflow markets across the country. We also have joining us today Mr. Sean Cleary. He's the Vice President of IAPMO, ASSE. He's here to share his expertise on code requirements and enforcement and testing. And I thought he has a good point of view kind of from the legislative side of backflow installation. We also have Mr. Joe Gildersleeve. He's the Water Resources Manager at the City of Arlington in Texas. He'll share his expertise on resource management and gives us a really good point of view of how municipalities actually protect your water. So I thought that was very important. Last but certainly not least, and Mr. Christopher Mayhew, President of Backflow Services, Inc., out of Richmond, Virginia. And he will share his expertise as a certified tester, installer, and contractor. And he puts his hands on backflow preventers just about every day. So, fellas, I certainly thank you for your time and appreciate you joining us.
Thank you.
My pleasure.
Good to be here.
All right. So we'll start out our discussion here. Our first question I'll direct to Joe. And just because as a, water resource manager, what is kind of the general practice in your area concerning the installation of backflows in vaults?
Well, here in Texas, we basically have the plumbing code and then the state or local code that we're enforcing. And then, so the plumbing is doing most of the internal point of use protection. And then the water utility is doing the external containment or premise isolation backflow. And in most cases here, we've got, when it comes to, we try to do what we call premise isolation from the facility in Arlington, where we're basically putting a backflow assembly on each of the water connections. So in general, you got irrigation, fire, and then the domestic usage. And most of ours has to deal with the commercial aspect. And so in that regards, our commercial domestic usage is our RPZ. So it's above ground and in an enclosure. Usually it can be inside, but generally we don't, it could be bigger than 2 inches, but we don't recommend that, just so that they can hopefully keep up with any full dump from the assembly. So when it comes to vaults, if that's going to be installed in Arlington, you're basically going to be looking at either fire protection or irrigation in those regards. And we're doing it right now, going through a lot of retrofits of fire sprinkler systems that have the old single check. And so putting them in a vault or putting them in an enclosure is what we like to see, the enclosure, but more often than not, it seems to be a vault that's getting installed. A lot of that discussion is, we've talked before, it becomes a price issue. But there's also aesthetics, visibility. You know, if it's going to have to be installed, it may be that it has to be near a drive or something in that aspect. So an enclosure could potentially block that visibility, especially on those larger systems for a fire sprinkler system. But in general, that's just kind of how our practice occurs here in Arlington.
About how many single checks do you have left? Do you got any feel for that?
Oh, I would say that we probably have half of them still, so maybe 450 would probably be a pretty good guess. That we're slowly getting to and having them change over. We kind of have different criteria where we like to see when we start to see movement on making them convert it back over into a double check. And there's guidance here in Texas on what's expected from the state on those fire sprinkler system.
Right, the TCEQ stuff.
Yes.
So when they're taking out a single check, you pretty much have to repipe the whole thing because most double checks won't fit in that same lay length. Is that correct?
Well, we're seeing derringers. It's a smaller footprint of backflow assembly that can go in some of these existing vaults. It works out really nicely. And a lot of those larger ones even could be, $5,000 just for the assembly. But the problem comes in is you got to have a licensed fire alarm sprinkler contractor come in and do calculations of the systems because you're putting the assembly in play.
Right.
So then once that happens, then you got a whole new criteria kicks in for the facility. So it becomes very expensive.
Yes. All right, that's a good thought. So I thought your point of view is interesting because, most of your new commercial installations, you guys enforce RPZ and above ground. And I see that all across the country. That's one of the big points of my presentation is just about everywhere in the country is going to that. We call it the rise of the RPZ for several factors, but mainly because it's better protection for your water supply. And you as a municipality, that's your water. You got to protect it. So I see that just about everywhere. But like
in a lot of cases here in Arlington, we don't know what the end user is going to be of that facility. So it's better to go ahead and have the highest protection that we can to protect our public.
Exactly right. The guy who's an office building today, 10 years from now, he's the cyanide manufacturer. So better to just go ahead and put that RPZ in. But I did think it was interesting that you do allow vaults, but like you said, mostly for fire protection. So you're having double checks and double detectors that are going in vaults.
In both fire and irrigation, the state deems that as a low hazard protection. So that's why we're still doing those double checks. Of course, if there's any chemical added, then it would be an RPZ required.
Gotcha. That's also an interesting point because that's kind of rare to have irrigation considered low hazard. But, anyway, that's interesting stuff. Going to Christopher, what's kind of going on there in Virginia? Similar standards?
Very much so, yeah. Typically, Virginia, we have, of course, the high health hazard, which is going to require the RP. Low hazard, of course, you can allow a double check. And if it is a double check, that's the only ones allowed below grade. So in the 3 domestic, fire, and irrigation, your domestic, there's some jurisdictions that will allow or will allow a double check on a domestic line. There are some jurisdictions that are pretty much reduced pressure RP assemblies across the board, with a few situations that they will allow that you can go back to a double check in a case of a fire or whatever, fire system. Of course, our irrigation, lawn irrigation is high health, so it's going to require an RP or a pressure vacuum breaker. And of course, neither of those can go in vaults. So short, if you got a vault, you should have a double check or a double detector only. And those are typically going to be 90% fire. I have a few in some of the municipalities that are going to wash downs that they've allocated as low hazard. And so they've got double checks in the pits.
Gotcha. Okay, since we're talking to you, as a tester and a guy who gets in vaults on a regular basis, what kind of safety precautions do you have to take for yourself or your team or your employees when they're getting down in a vault?
Well, anytime that I'm going up and down steps or ladders, anytime I'm getting off a grade, whether it's going above or going below, we have to take additional steps. One rule is that I do not go into vaults by myself. Not that I have to have somebody else in the vault with me, but I'm not going to be on station by myself. So if that requires me to have an additional employee with me or a member of the property, whether it be engineer or a municipality utility worker or whatever the case is.
Gotcha.
First of all, we inspect all of them, and I'll tell you, my experience is all vaults flood, and there's a very few of them that I get to that we don't have to pump out. The picture you're showing here is a prime example, and I don't pump water. That's not part of my job as a backflow tester. So the owner or the municipality or whoever it is that I'm doing the work for has got to have a crew there. They've got to have a submersible pump and be able to pump it down to where, I can get down there. I'm not afraid of standing in water by no means, but I'm not standing in knee-deep water to test a backflow. And of course, with that is additional cost. Your costs, your test costs are going to be higher. It's going to cost you more for me to come out and test one in a vault, especially if it's flooded, than it will be to test one above ground. We've got to have the assets. We've got to have a pump. We've got to have crew. We've got to pump it out. Then I'm going to get down there. Of course, I'm usually standing there waiting for it to get pumped out. Mm-hmm. And you're going to typically pay me for my time. So it will generally cost a little bit more for me to test a vault than it does to test anything above ground. And then hazard-wise, you got your slip and falls, your vaults that have been dirty, wet. They got scum on the steps. Of course, you got critters. Don't forget your critters.
Always spiders.
You got to love your critters. And not even to get into the argument of confined space entry or permit entry. That keeps coming up. And of course, none of the jurisdictions that I work in here in Virginia have permit required entry for their vaults. A lot of them don't really know, not really sure whether they should be permit entry required or not. Of course, they are confined space. There's no question. The definition in OSHA, definitely, there are confined space. But there again, when I open them up, I take my time. We don't use sniffers, anything like that, but I do open them up and give time for the critters to move around. Of course, if we got to pump them out, we wait to get them pumped down. And then, of course, when you're going in and out of them, you just have to be careful. And unfortunately, I don't get around as good as I used to. So,
None of us do.
yeah, so it's a little bit more of a task some days. Some days the knees don't work as good as others. And so you're dealing with that. So, again, it's maintenance-wise, cost-wise. If somebody was to sit down and roll some numbers, you could probably start to see in the lifetime of a vault where you could definitely have a return on investment by having it above ground and in the enclosure. Again, I got 2 utility guys with me pumping the vaults out. I'm standing there. I do charge my customers more because I know I can't show up and just test one in 10 minutes. It's going to take a while. So the cost, and of course, by the pictures you're showing here, everybody knows the ball valves degrade, the valve handles degrade when these things are exposed. University of Southern California dictates that if the valves, if the test cocks are submerged, that's considered a cross connection, whether they're open or closed. So you look at those pictures, and you've got basically 4 cross connections every time the water gets at or above the test cock locations. So I'm looking at those pictures, and I could count 4 cross connections. And if we go back to the Safe Drinking Water Act, the EPA states that we shall not have cross connections. So that's kind of my take on the vaults.
Very good info. We appreciate that, Chris. Like you said, OSHA does classify it as a confined space. So if you were following all the OSHA confined space rules, you would have to have a sniffer and an extra person and a tripod and all those other things that OSHA requires. I was down at the ABPA convention a couple weeks ago down in Orlando and talked to a guy named Jeff Smith. And all he does is sell confined space safety equipment. That's it. And his 4 main precautions when entering a confined space are gas detection, fall protection, ventilation, and communication. So you got to have something for all of those 4 things before you even think about getting down in there. So to your point, it costs a lot more to maintain a backflow installed in a vault. So good stuff, Chris. Appreciate it. We'll keep moving on. I wanted to direct a question to Sean at IAPMO. He's got a long history in this business as well. We kind of talked briefly about high hazard and low hazard applications. That's been language that I've heard, my whole 20 plus years in this business. And I know everyone on the call is familiar with backflow, knows about high hazard and low hazard. But I wanted to kind of get like a historical perspective on that. Where did that kind of language come from?
Well, the language has been around in the codes for quite a while. We have 3 model plumbing codes in use in the United States, which would be the Uniform Plumbing Code that IAPMO writes, the International Plumbing Code that the ICC, the International Code Council, writes, and then the National Standard Plumbing Code, which is really only used in a little bit of Maryland and parts of and the state of New Jersey. But all of them, recognize the high and low hazard classifications. The low classification is something that will only affect the aesthetic quality of the water. And then the high hazard is anything that can make anyone sick or, God forbid, cause an illness to the point of death. So all of the codes have a standard written right into them and lays out which valves are used in which situations. One of the discussions you were having before was about irrigation systems. Irrigation systems are always high hazard because of the chemicals and everything else that people put on their lawns and all that. So all 3 of the model plumbing codes, no matter where you live and which one you're using, are very clear that that would be a high hazard situation because a backflow incident could cause illness or death. Now that language has been written into the code since the late 90s, early 2000s. So they've been through a number of code cycles where that's been made very clear as to there is a definite difference between high hazard and low hazard.
Mhm.
And the code allows you to pick the valve that you need for the proper situation. We know that buildings can change usage and things like that, but the way the code looks at it is, isn't that everything commercial gets an RP and everything residential doesn't need anything. They're looking for specific usage and then the specific protection that's needed. Because if you don't need an RP, you don't need that pressure drop, you don't need the issues we have with relief valve capacity and all those other things. So those are, some different things to take a look at. The codes, when it comes to the actual vault installations, are very clear. You can't put a valve that has a relief valve or has an air inlet valve, you can't put it below grade. You can't put it anywhere where it could be submerged. Even if you go with this drain to daylight part, the ICC, the International Plumbing Code, says, they say for accessibility, we have to go with manufacturer's instructions. And Watts and Wilkins and Apollo are very clear that we don't put valves in pits or vaults. We don't put valves in there that have inlets. So, that is pretty well taken care of. And because of the drainage capacity, it's something we really have to think about. Just about every picture that you've shown so far in this presentation is a permit required confined space. So it's crazy not to do air monitoring or harnesses or lifts or all those kind of things when you're going into a confined space like that. You have no idea about algae blooms or anything else that could happen with toxic fumes in there. And we've had too many fatalities over the years in the industry as a result of the issues like that. So it is important to understand that. I agree with some of your other panelists who said it's more economically feasible for someone to put a valve in an enclosure because of the testing requirements and the safety requirements and the code compliance that you have with putting things in pits and vaults.
Excellent point. Yeah, no, I kind of started in the rep business, where you just call and you're talking to everybody all during the day. And as an inside sales guy at a rep firm, I would get calls from municipalities and engineers all the time saying, which backflow does this application need? Is this high hazard or low hazard? And I'm like, I don't know. I'm an inside sales guy. I've been here, 3 months. I probably shouldn't, I'm not qualified to answer that question. So it's not.
Yeah, and like I said, in all honesty, there's a table in each of the 3 model plumbing codes that lists the hazards, lists the type of backflow, lists the protection that's required, and you can go right down it. Now, certain jurisdictions might amend the model codes because that's what they're for, but the model plumbing codes do a pretty good idea of telling you what belongs where and how it should be installed.
Okay. That's good stuff. Okay. Let's talk, let's go back to Joe, since you're the municipal guy. Knowing the hazards and dangers of vaults, you and I have discussed those before. It's one of the reasons why your standard details are so clear on above ground installation. But do you think there's any time in the future where vaults would be like outlawed or not allowed?
What if it ever goes to a high hazard status, obviously, then that would be the case for sure. Same thing kind of pertains to that. I'm talking about fire sprinkler systems and then irrigation as well. And that's kind of under review right now by the state, is whether or not our irrigation systems will be deemed as a high health hazard. And then that would trigger retrofits, obviously, to go in and start putting in above ground enclosures. If that happens, then I would say yes. Usually it's coming from a higher up than the local authority.
Right. And, it's just kind of an opinion question. I'm from the South, in Georgia, it's very common for vaults. I know in Texas, it's definitely the norm. Pretty much we're in the Sun Belt, they pretty much put them in vaults. So it's definitely a hard habit to break. Whether that's, ever going to happen, certainly we want to educate and tell people the dangers and the requirements and, the hazards the best we can. And hopefully knowledge will win out. It's pretty much our philosophy. Just quickly, I know we're about to run out of time here. We don't want to keep everybody on too long. But I did want to, Chris, you had mentioned the major differences in time and cost as far as testing in a vault. How is it easier when the backflow is installed above ground in an enclosure?
Oh, well, I mean, yeah, we're going from opening a cover. If you'll flip to your last slide where it shows the concrete portions, I mean, that's obviously, where you're picking up, pieces of concrete and repositioning them versus a, metal door where you just unlock it and pull it open. Hopefully it's hinge assist, so you don't have to lift so much of a heavy door. But just obviously get it above ground. All you're doing is opening up the enclosure, depending obviously on the size. I've got twin 6-inch 994s in an enclosure. You open up the doors on both sides, let the air through. Got room enough to get inside and work on them. Obviously got plenty enough room to test. It's all above ground at grade. No climbing, no fall hazards, no hazardous fumes or anything like that. And one other thing too, on the way this picture is depicted, obviously we of course the nice little pretty picket fence, which I'd go to step over it and trip and fall and impale myself. So that would be an issue there for me. But we mentioned this yesterday. Does anybody has anybody ever had a situation where you were testing a backflow in one of those pits and somebody's on their cell phone not paying attention and drives a car over top of the pit or into the pit? We've seen YouTube videos of people driving through bank drive-throughs and restaurants and things like that. And so this is a case here where it's not protected by bollards or anything, or guardrail or whatever, to keep vehicular traffic from come crashing in on top of you. So that's an issue it would still be there if it was above ground, but you have at least an area to try to escape from if something like that was to happen.
Yeah.
But just real quick, one of the thoughts that I have on this whole vault deal, there's two things. You're either going to mandate it out of practice by writing codes, getting legislature or whatever the case is to either outlaw them or make it to where you can't. It's not feasible to have them in the ground. And the other sense is, of course, to incentivize people, make it to where it's cheaper or as economical to have them above ground in an enclosure than it is to put them in a vault. And really until, maybe perhaps until we get to thinking on those two lines, we can, as a contractor, you make it to where it's easier and cheaper for me to put it above ground, guess where it's going? I mean, that's no questions. And then of course, the only other sense is that you outlaw it or make it to the point that we got to go through so many bells and whistles, then it still ends up probably more economical for us to go above ground than in vaults. I don't like vaults. I wish they wasn't there, but they are. And it kind of goes back to the double checks or RPs or whatever. If it meets the code and you can do it, then, of course, folks are going to do it. But it's definitely more expensive to have them in the pits, maintenance-wise and, service-wise.
So, Sean, on those lines, what would it take to get get vaults, mandated out or legislated out?
Well, I think a lot of it boils down to authorities having jurisdiction, allowing things that aren't allowed in the code. I mean, what you're looking at there isn't allowed in the code. you're not, the uniform plumbing code is incredibly clear saying you can't put pressure vacuum breakers or RPs or anything like that in pits or vaults. It's prohibited. You just can't do it. And then also, this is one of the biggest frustrations I know guys, backflow testers and code people like myself have, is the fact that it comes down to enforcement.
Right.
You know, for you to go into the pit that's shown on the screen right now, and for you to do it without a harness, without a lift, without an attendant, without air monitoring, without forced ventilation, is a violation of OSHA statutes. And God forbid if, you know, someone went into that pit and died, believe me, then it would become a big issue. You know, the problems we have is what I like to call tombstone regulations. We wait until something horrible happens, and then that's when people, you know, start looking at it a little better. But code-wise, you can't put it in a vault or a pit. OSHA regulations-wise, you can't just climb into, well, you can't break the grade and go below ground without a bare minimum of air monitoring, a tripod, a harness, a lift. You know, that's the way the regulations read now. It's just a matter of enforcement of those statutes. And, you know, it's terrible to say, but OSHA investigates things after there's a fatality instead of in a lot of cases before.
All right. So
but I mean, look, you know, yeah, putting an RP in a pit or a vault, you're already violating the code. You know, we can argue about berm installations and things like that, and drains to drainage, you know, drains to atmosphere and all that. But, you know, are you properly set? The picture you have there now, that's a pretty big valve.
Yeah.
Exactly what size drain do they have on that valve? I don't know if it's an RP or a double check. I can't tell from that position. But if that was an RP like that in a pit, that looks like an 8-inch valve. You would need a 12-inch drain to atmosphere. I don't know where you would get that.
Yeah.
And that's what I mean. So the manufacturers and everything tell you, and if you go by their specs and you go by the code regulations, we wouldn't be seeing valves being installed like this. But I think, as the gentleman before me said, a lot of it has to do with cost. And until you incentivize people to put it above ground, when it's cheaper to put it below ground and people are willing to, shall we say, you know, turn the other cheek and allow installations they probably shouldn't, you're going to continue to see it. It's a perplexing situation, and I don't think there is a one-size-fits-all solution.
Yeah, that's a good point. So there's a lot of codes and regulations that are already out there. They're just not always enforced. So
yes. And it is tough. It's tough to go into an existing business and tell somebody, you know, the valve you have in the pit or a vault, you really need to spend $20,000 to put it above ground.
Yeah,
that's a tough pill for anybody to swallow.
Right. As far as costs go, I mean, we did a pretty general breakdown. Obviously, costs vary wildly across the country, but on a general basis, we found that, you know, installing a backflow above ground in an enclosure is most of the time equal, if not less, than doing it in a vault. So you gotta, you know, if you break down the numbers, certainly equal or less than in our study. So,
well, I'm sure it would make perfect sense. And as I said, if you're testing them correctly, it drives the cost up and up and up, and year to year to year, you definitely get your payback quickly.
That's right. Well, I think we've about run out of our time. Is there anybody have anything else they wanted to add?
I'd like to do a shout out.
Let's have it.
Our good friend, let's see, let me look, John Hudak. He's on here. Murray McDowell, he's probably up north of the border. And see that he's on here. Good to see those folks on here. And really appreciate everybody else being here also. Thank y'all.
Thank you.
Yeah, we certainly appreciate your time, Joe and Chris and Sean. We sure appreciate your time on this and sharing your opinions. And, you know, that's all this is really. We just want to discuss and we'll talk about different things around the country. And we just like discussing anything about protecting the water. So if nobody else has anything to add, we once again appreciate your time. Brittany or Craig, you guys have anything?
Did we have any questions from the participants that we might answer?
Yeah, I've got one that was interesting. They asked, is there any time when a vault is preferable to above ground just because of space? They said sidewalk space.
Well, I know like in the city of Seattle, you know, where everything's crammed in downtown, we've had them come up. We put them inside a flower bed. So instead of putting it inside, they you know, piped it where you could come up and, you know, with like an end pattern backflow. It's a very small lay length and very small enclosure. And we basically installed it in a flower bed. So it's, you can hide them pretty well, pretty easily.
And then someone else asked if we could talk about inside versus outside, but I think that is a whole new discussion and maybe for next time.
Yeah. It's a bit of a wormhole.
Yeah.
Yeah.
All right. Well, I'd certainly like to thank everybody for their time. It's been great. I've enjoyed the discussion.